Hello, this is Elijah Peters. This is week 3 of data structures and algorithms. This week is used with stacking queues, so FIFO and LIFO. First in, first out, last in, last out. So let's just get into it. So we're using the Euclid's algorithm, the subtraction one. If m is greater than n, then the switching and finding the greatest common factor. So getting into the algorithm class, this specific class replaces the file handling in the last Euclid's algorithm and handles it with a stack and traces the execution steps. So it reports the data and uses a stack to trace the steps this time. So we don't have to use file handling and have a path for everything. So it's the same type of steps if n is greater than m, and then the swap count. And this time it just traces it with the stack and says the initial swapping m with n. And the same conditionals with just while m is equal to n, if m is less than n, then swap again, swapping m with n, and it'll trace it and push it out to the report. And then it traces also the subtraction and shows the result in the report. And this last one just traces the final greatest common denominator result and puts it in a string format in the report at the end. And it just tracks the time, the start time, end time, which it should be faster than the actual original algorithm because stacks and queues make the time a lot faster. So getting into the Euclid's lab, we have this is the driver to run all the tests. So it uses a queue in this instead, and it reports all the objects, or it collects all the report data objects before writing the final report. And it uses a queue to collect all the data in the first in, first out order, so FIFO. And it has a random generator for numbers for each test, so I think 200 to 5,000 or 100 to 5,000. Runs the algorithm, adds the report data to the end of the queue, and prints out the completed run with the all the data, like the switches, the time, m and n. And then it uses a queue for processing and the report generation, so it writes the header once, and then a pull command retrieves and removes the head of the queue, so everything's in order. And then the last, it just prints out the performance summary and the final report. And if we run it, actually the report data too. So this is all the same. The only thing is the line count is different now because it represents the number of trace steps stored in the stack. But if we run this, you'll see that it runs all 100 tests. And then if we go out and go to the report, we'll see that it's got like an extra 0, so it's a lot faster than the actual Euclid's algorithm before. So it added a lot of time for that file transferring over to that report. And that is week 3.